Hai and Assalamualaikum warahmatullahi wabarakatuh. Today we will be presenting about this, which is incorporating recycled waste material, which is coconut shell, as aggregate replacement in sustainable concrete. So for our introduction, my name is Wan Muhammad Dini bin Abdul Malik. My matrix number is 2023-464 and 368.
And my name is Ahmad Zuhilmi bin Ahmad Zaini. My matrix number is 2023613 and 444.
And my name is Muhammad Afiq Farhan bin Muhammad Suriza, and my matrix number is 2023645116.
My name is Adam Mikael bin Shahrul Nizam. My ID matrix is 2023607956.
Where coconut shells are used as a
Okay, so these are the 10 articles involved in our project,
crushed stone,
and this is the raw
instead of
article that we
using
chose
100%
for our
conventional stone, a small percentage, for example 2% until 8%, is replaced with clean, dried and crushed coconut shells, usually discarded as agricultural waste. This concrete is designed to be more eco-friendly, utilizing renewable waste material without coconut shell as aggregate, compromising strength, especially at waste source. Coconut shells are widely available in tropical countries like Malaysia and are usually discarded. Number 2 is environmental benefit. Reduces landfill waste and minimize attraction of natural stone, helping to preserve natural resources. Number 3 is lightweight. Coconut shells have a lower density, making the concrete lighter, which can reduce the structural damage. Number 4 is cost effective. As a waste material, coconut shells are cheap or even free, reducing construction costs. Lastly is sustainable development. Support circular economy and aligns with SDG 12, responsible consumption and production,
So for
and
methodology,
SDG 9,
for our
industry,
materials
innovation
used,
and
we have
infrastructure.
cement, which is we used OPC, ordinary Portland cement. For fine aggregates, we use clean river sand. For coarse aggregates, we use crushed granite, and it is partially replaced with coconut shells. And for our coconut shell, it was dried, it was cleaned and crushed to sizes similar to coarse aggregates, which is about 10 to 20 millimeters. And so for water, we use clean tap water. And so for mixing design, for our mix design for grade 30 concrete, based on the Department of Environment method or equivalent standard, the following mix ratio was used for C30 concrete was 1 to 15 to 3. 1 for cement, 15 for fine aggregates, and 3 for coarse aggregates. And so there's also a water cement ratio, which is 0.5. Okay, so for target strength, it is 30 MPa at 38 days. And for water cement ratio, it is 0.45. And for cement content, it is 430 kilograms per meter cube. And for water, it is 193.5 kilograms per meter cube. And for fine aggregate, it is approximately about 645 kilograms per meter cube. And for coarse aggregate, it is again approximately about 1,290 kilograms per meter cube. It is also partially replaced by, the coconut shells. So for our mixed variations, the concrete was prepared with 5 different proportions of coconut shells replacing the coarse aggregate by volume. So the first volume is 0%, which is the control, and then there's 2%, the 4%, 6%, and also 8%. And so for mixing and casting, the next step, each concrete batch was mixed thoroughly using a mechanical mixer to ensure uniform distribution of materials. So fresh concrete was poured into standard 150 millimeters multiplied by 150 millimeters, again multiplied by 150 millimeters cube molds in 3 layers. So each compacted using a tamping rod. And so for the next step, we have the curing step. So after all those work, we have to do the curing step for our concrete. So it is basically after 24 hours of setting, samples were demolded and cured in clean water at room temperature for 28 days.
The conclusion of cost
to
and
ensure
pressure
adequate
is coconut shell reduce the need for
So for
natural
our last
stone,
step,
which lowers
we have the
material
compressive
cost and
strength
supports
test.
waste
It
utilization.
is very important for us to test the
4%
strength of the concrete.
substitution is used.
And so after the curing, the concrete
In
cubes were
evaluating
tested
the
for
cost
compressive
efficiency
strength
of using coconut shell as partial
compression testing machine,
replacement for coarse
ECS,
aggregate in
according to
concrete, the result
ASTM
indicated more
nice or
right?
equivalent
meaningful
standards.
reduction in
So
overall
the average strength of 3
material
cubes
expense.
for each mix
Convention
was
grade
recorded and compared.
30 concrete.
Okay, so that's all for
consists of
methodology.
cement, fine
Thank you
grade,
very much.
coarse aggregate, and water in a standard 1 cubic meter cube. Means the estimate cost breakdown include approximately Rm 140 for cement, 60 ringgit for fine grade, 100 ringgit for coarse aggregate, and 5 ringgit for water, bringing the total to around Rm 305 per meter cube. When substituting 2% till 4% of the cost aggregate with coconut shell, the cost of natural stone reduced slightly as coconut shell is considered agricultural waste and are often available little to no cost. The uses of 2% coconut shell reduce the cost aggregate portion by about RM2, while a 4% substitution may reduce it up to RM5. The total estimated cost of the modified concrete mix would range from RM295 to RM300 per meter cube. While the savings may seem minor per unit, they become significant at scale, especially for large construction projects. Additionally, this substitution provides economic benefit beyond raw material costs, such as reduced transportation and environmental disposal cost of agricultural waste. However, at higher substitution levels, like
Economic
6% till 8%, the reduction in strength could lead to increased material volume or reduction for structural application, which may offset the savings. Therefore, the use of coconut shell in small percentage, 2% till 4%, offers a practical balance between cost efficiency and performance, particularly for non-structure or lightweight concrete
affordable housing project or rural development. For community impact, income generation for farmers. Selling coconut shell creates an additional income stream for coconut farmers, especially in rural area. Employment opportunities. Shell processing creates small-scale jobs in local industry. Support local resources. Encourage the use of locally available material, reducing dependence on imported or distinct resource. Industrial impact. Lightweight concrete production. Coconut shell concrete is lighter in weight, which is beneficial for precast product, non-load bearing wall and transport related. Environmental impact. Waste management. How the utilize agricultural waste that would be otherwise be burned or dumped. Malaysia is a major producer of coconut. Reduce the demand for natural agriculture, often thereby minimizing environment. Present a strong degradation caused by coconut shell as a sustainable construction material, particularly in the production of lightweight concrete. The current usage of coconut shell in Malaysia. In Malaysia, the use of coconut shell in concrete is still mainly limited to academic research and experimental application. University and technical institute are actively studying coconut shell concrete in laboratory setting to evaluate its mechanical properties, workability and potential application. For example, pavement block, precast boundary wall, flooring slab, low-cost housing element.
So for this slide, I want to explain about discussion of this project. The use of coconut shell waste as a partial substitute for coarse aggregate in concrete reflect a significant step forward in the development of sustainable construction materials, as demonstrated in the study by Muhammad Yazid. The agricultural byproduct usually discarded or burned can be repurposed to reduce the environmental impact of concrete production. The results show a clear trend. Increasing the percentage of coconut shell leads to reduction in compressive strength. This is largely due to lower density and different surface texture of coconut shell compared to natural aggregate like crushed.
So for our third team slide, we have the
Its
current
pores
research
and
and
fibrous
development of
structure
product.
may
So
weaken the
let's
bond
start.
between aggregate and cement base,
Research on coconut
resulting
shell
in reduced
concrete
mechanical
shows
performance.
compressive strength
However, at
reducing
lower
for
substitution
partial
levels,
replacement of
the
coarse
strength remains
aggregate.
within an
But
acceptable
it is
range,
still good
making it
quality
viable
for
for
lightweight
non-load
and
bearing or light
non-structural
structural
uses.
component.
For
At these
example,
levels, concrete
coconut
still
shell
demonstrates
is
sufficient
suitable in
compressive strength,
blocks,
while gaining major
fortifications,
environmental
and also also
including
light
reduced use of
substances.
natural resources,
So,
decrease
also,
in agriculture,
research indicates
waste
that slightly
accumulation, lower carbon footprint in sourcing
slightly
and
increase in
transportation.
water
Moreover,
absorption for
coconut shell
shells.
aggregate are lighter
Yet,
in weight, which
durability
may
can
be
be improved
advantageous
through
in
additives
reducing
such
dead
as
loads.
fly
Certain
ash
types of
or
construction
silica fume.
such as
So,
lightweight precious
additionally,
elements,
the lightweight
rural
nature
housing
of coconut shell concrete
eco-friendly
ultimately
infrastructure.
helps to decrease the structural loads produced, which can decrease the overall construction cost. The process of reusing agricultural waste as an alternative for natural aggregate is sustainable construction materials process that contributes to sustainable construction overall. Coconuts are an agricultural waste that will
For
continue to be
conclusion, this
manufactured for
study concludes
years.
that coconut
While
shell waste
coconut
can be
shell
successfully
concrete may not
utilized
replace
as a partial
other concrete
substitute
options
for
for
coarse
structural
aggregates in
hierarchies
concrete,
yet, there are
particularly
many
in
continued
application where strength
innovatives
requirements are modest
such as
with
hybrid
2 until
mixtures
4%
with natural and
substitution rate.
synthetic
The
aggregates,
concrete retains acceptable
nanomaterials,
composite
and
strength
also
while
3D
offering key
printing
environmental
technology,
and economic
expanding the
benefits.
potential of
The
coconut shells
incorporation
concrete.
of coconut shells.
So,
The first one
continued
is
research
promotes
and
waste
future
management and
standardization
supports
may
circular economy
prove coconut
principles.
shell concrete
Second
as
is
an
reduce the
environmentally
reliance on natural
friendly
aggregates,
material
which are
substitute
becoming increasingly
in the
scarce.
building industry.
Number 3 is
So, that
lowers
is
the
all
carbon footprint
for
of
our third
concrete
news slide.
production.
Thank you very
Lastly, it
much.
offers cost advantages by using locally available waste. However, compressive strength begins to drop significantly at higher substitution rates, 6% and 8%, indicating a performance limit beyond which coconut shell is no longer suitable for standard concrete use. Therefore, its application is best suited for non-structural or semi-structural elements, especially in low-rise buildings, pavements, or community infrastructure where sustainability is a priority. Going forward, further studies should investigate the long-term durability of concrete with coconut shell, ways to enhance bonding and strength through chemical treatments or supplementary materials, the feasibility of scaling up this approach for use in commercial construction projects across Malaysia. In summary, coconut shell concrete provides a practical, sustainable alternative for selected applicants and represent a meaningful step toward greener construction technologies in line.
In the context of Malaysia, where coconut farming is abundant, this innovation holds significant potential. It aligns well with national sustainability goals and promotes localized sourcing of material, minimizing cost and transportation energy. While compressive strength remains a limitation for structural application, further research may explore combining coconut shell with strength-enhancing additives such as fly ash, silica fume, and fibers to improve performance without sacrificing sustainability. There is also potential for surface treatment of coconut shells to improve bonding with the cement and paste.